So classified thermal physics question, you can use chat, mic, or annotate on the screen to answer these questions. Describe the movement of the molecules in solid, how the particles in a solid are moving. So vibrating about a fixed position, and how the molecules are moving in a gas. That's right, vibrate about fixed position. And this one moving randomly. So gas random motion is here, solid vibration about fixed position. We have a closed box contain a gas molecule in terms of momentum, how they exert. This is a very important question. Like you will find this question repeated in many past papers. So what is the structure of the answer? First thing, you will mention the gas molecules are moving randomly. And hit the wall of the container. Change direction and the momentum. The change in momentum, due to the change in momentum, exert force, and the force on unit area will create a pressure. So this is always the case whenever you see a question to relate the momentum and the pressure, you should always use these 4 points. The gas molecules are moving randomly. Gas molecules changes their direction when they hit the wall. And because of the change in direction, there is a change in momentum. And because of the change in momentum, they will exert force, and the force on a unit area will create a pressure. In this question, a gas of mass 0.23 gram is trapped in a cylinder. The gas is at atmospheric pressure, which is 1 exponent 5 Pascal. Figure 4.1 shows the piston is held in the position by a catch, means like the stopper is there, which you can also say a catch. The volume of the gas which is trapped is 1.9 exponent minus 4 meter cube. An electrical heater is used to increase the temperature of the trapped gas by 550 degrees centigrade. The specific heat capacity is given 0.72 joule per gram. Calculate the energy required. Whenever, look, the unit of specific heat capacity is important. As you can see here, the unit of a specific heat capacity is joule per gram. So we don't have to convert the mass into kilogram. If the unit of the specific heat capacity is kilogram, then we have to convert the mass into kilogram. So here we don't have to convert. So we use a formula the formula which relate the energy and specific heat capacity. So E is equals to Cm delta T. The heater increase the temperature, so delta T is 550. The mass is given 0.72. And the specific heat capacity is, the mass is given 0.23 and the specific heat capacity is 0.72. So 0.72 times 0.23 times 550. So this will give us 91 joules of energy is supplied. The power of the heater is 2.4 watt. How long it will take for a heater to supply the energy we calculated in A1? We calculated the energy supplied is 91. So the formula which relate the power and energy, power is rate of energy transfer or energy divided by time. So we have the power which is 2.4 Energy we are supplying 91 and time we don't know. We cross multiply. So the time will be equals to 91 divided by 2.4, which is 37.955. Always write in three significant figure. So if you write 37.9 second, that's also fine. In practice, it takes much longer to increase the temperature of a gas. Using the heater suggests one reason for that. So whenever you're supplying heat energy by using an electrical heater, what might happen? Some of the heat transfer to the surrounding, or heater might takes time to reach a certain temperature, because it's not like you switch on the heater will also become warm and then it supply the heat energy. So or heat loss to the surrounding, or heater takes time to heat up. When a temperature of a gas increases from 550, its pressure is 2.9 exponent 5 Pascal. The catch is then released and allowing the piston to move. As the piston moves, the temperature of the gas remains constant. State and explain what happened to the piston. So when this gas in the question, when this gas reaches 550, the pressure from inside is given. The inside pressure is given 2.9 exponent 5 Pascal. So the inside pressure is 2.9 exponent 5 Pascal. And what was the outside pressure? The outside pressure in the beginning, because atmospheric pressure is outside pressure, which is 1 into 10 power 5 Pascal. And this catch is being removed, means the stopper is removed. So what happened to the piston? Where it will move? So this will move outward. So the piston will move outward. And the reason is that because the pressure of the gas inside is more than the atmospheric pressure. And then eventually it will stop. Because if the temperature is not changing, so means if you increase the volume, the pressure will decrease. So eventually what will happen? The piston will stop at certain position. When the piston will stop, it means the outside pressure and inside pressure will be equal. So the points you will mention here, state and explain what happened to the piston. It will move outward or move towards the right, because the inside pressure or a gas pressure is more than atmospheric pressure. And eventually what will happen? When the gas expands, the pressure decrease. So piston will stop when outside and inside pressures are equal. Determine the volume of a gas when the piston stop moving. So for this, because whenever a gas is there and you have to determine their volumes, you have to use Boyle's law. So according to Boyle's law, we have the formula P1V1 equals P2V2. Look, initially the gas was at this pressure. But what happened when we supply the heat energy and we reach a 550 degrees centigrade, the pressure of the gas is 2.9 into 10 power 5 Pascal. So that will take as P1 now. Then when the piston, as I mentioned, the piston stopped moving and the catch is already removed because it's a continuation of the question. So the catch is removed, the stopper is removed. So as a result, what will happen? The piston will move outward. And when the piston, so this is the initial pressure P1, which is 2.9 into 10 power 5 Pascal. And what was the volume of the gas? The volume of the gas which was trapped initially is 1.9 into 10 power minus 4. P2 is the final pressure. What will the final pressure once the piston stop moving, it means the outside and inside pressures are equal. So if the outside pressure is 1 exponent 5, the atmospheric pressure, so the inside pressure, the final pressure will also be 1 exponent 5. And then we need V2. So if we need V2, this will go there in division. So it will be 2.9 into 10 to the power 5 multiplied by 1.9 into 10 to the power minus 4 divided by 1 exponent 5. So that will be V2 when we simplify this. So 1 exponent 5 cancel with this. So 2.9 into 1.9. So it will be 5.4 exponent minus 4 meter cube. Because the volume is given in meter cube, so that will be meter cube. Is it clear, discussion? The next is about the boiling, how two ways they differ from each other. In both boiling and evaporation, liquid is changing into a gas, but how they differ or what is the difference between them? Boiling has no fixed temperature. Boiling occur at any temperature. Sorry, evaporation occur at any temperature. Boiling can have a fixed temperature, that's right. Evaporation only occur at the surface, boiling throughout the liquid. Before injecting a patient, a doctor wipes a small amount of a volatile liquid onto the patient's skin. In terms of the molecule, how this procedure cool the patient's skin. So what will happen, like example, this is skin. The doctor is using a volatile liquid to clean the patient's skin, but how this cool down the skin? So what will happen? The most energetic molecules so in terms of, you have to mention like the most energy because you have to use this is a very general answer. You have to specify like particles absorb energy from uh, like particles absorb energy from surrounding and they escape and leave behind less energetic, but try to use the term skin and the liquid a volatile. So here the most energetic molecule of the volatile liquid gain energy from the skin and they escape. So the molecules which are left behind, they will have low energy, so the temperature of the skin will decrease. Gases can be compressed, but liquids are incompressible. Why? Why gases are compressible? Because the particles have large spacing. While liquids are incompressible because the particles are touching each other. They can move past each other, but they are touching each other. So in a gas, you can say large spacing between the particles, but in a liquid, the particles are touching each other. So they cannot come closer. So these are some questions from thermal physics.